This is section 3.6, and today we're going to be talking about how to prove theorems about perpendicular lines. We've done a lot lately in this chapter with parallel lines, and today we're going to focus on things that are perpendicular. So after today, you're going to be able to prove and apply theorems about perpendicular lines. So we have a couple of theorems we have to talk about. There are 5 of them that we're going to talk about before we do an example, and it's all kind of stuff you already know. We're just giving it more official math words, okay? So the first theorem says if 2 lines intersect to form a linear pair, so that means they make 180 degrees, it means they're a straight line. So I'm going to put straight and 180 right there. Form a linear pair of congruent angles. Okay, so now we're saying that they have to be equal to each other. So if they make 180 degrees, 2 of them, and they have to be congruent, then we know that those angles are exactly right, and that means that they are perpendicular, okay? So that means if angle 1 is congruent to angle 2, then G is going to be perpendicular to H. They're going to be perpendicular to each other. The next theorem says if 2 lines are perpendicular, so we're starting with knowing that they are perpendicular, then they intersect and form 4 right angles. So if A is perpendicular to B, then angle 1, angle 2, angle 3, congruent angle 4, and they are all 90-degree angles. So they're all equal to each other, which is kind of a duh thing. I think you guys know that. If they're perpendicular and one of them's a 90, then all of them are 90s. So again, it's not new information. It's just kind of, we're just putting it together in a theorem. Next one says if 2 sides of 2 adjacent acute angles. Okay, that's a lot of vocab right there. So 2 sides of 2 adjacent. Adjacent just means touching. So these angles have to be touching. They have to be sharing a side. Acute just means less than 90. So 2 angles that are less than 90 are perpendicular. So if their 2 sides make a 90-degree angle, then the angles are complementary. Well, it's kind of duh. You get 2 angles that add up to 90, then they are complementary. We know that. So if BA is perpendicular to BC, so we're talking about these 2 right there. If they're perpendicular, then angle 1 and angle 2 are complementary. Again, that's not a surprise to you guys. If I put a 45 there, you would know to subtract and get 45 there. I shouldn't have done that because then they're equal. If I put a 60 there, then you guys could have subtracted and figured out that that was 30. That's not something new to you. You've been doing that for a while. Next one says if a transversal is perpendicular. So now we've got 2 things. We're chopping it with a transversal. If a transversal is perpendicular to one of 2 parallel lines, so these guys are already parallel, then it has to be perpendicular to the other. Okay, so that's like corresponding angles. And if these guys are parallel, then the corresponding angles are equal. So if that guy's 90, then that one has to be. So if H is parallel to K, and J is perpendicular to H, that's the one we had that 90, then J is also perpendicular to K. So you get both of them. You kind of get a 2-for-1 deal there. Last one says in a plane, so if 2 lines are perpendicular to the same line, then they're parallel to each other. Kind of the opposite of this guy. If I have both of these guys being perpendicular, then they're parallel to each other. Then I can mark them as parallel. So if M is perpendicular to P, and N is perpendicular to P, so it's got to be perpendicular to both, then M is parallel to N. They're parallel to each other. Again, not a whole lot of new stuff, just kind of putting words around stuff we've already been doing. This is the hardest question you do in this section, is determining which lines are parallel and explain how you know. When you're doing that, you want to pick 2 lines and talk about them. So we'll start with S and T first. And we'll just talk about these 2 lines and we'll see if we can determine if they are parallel. So S and T. So what I'm looking for is something that touches both of them. So this would be a line. P touches both of them. But there aren't 2 angles that I can talk about. So I'm going to keep going. Another thing that touches both of them is Q. And they do both have an angle that I can talk about. They both have a 90. And they are corresponding. So those guys are equal. And if the corresponding angles are equal, then the lines are parallel. So S is parallel to T because both are perpendicular to Q. So that would be my reason. I'm going to look at T and U now. So doing the same thing, I'm just going to see the first thing they both hit is P, but there's no angles here for me to talk about, so I'm going to keep going. They both hit Q, but I only have one angle to talk about. I don't have anything over here. So those guys are not parallel. Let's try S and U. So tracing down, they both touch P, but there are not two angles to talk about. They both touch Q, but there's, again, not two angles to talk about. I don't have anything to compare with that 90. There's nothing there. So let's turn the other way and go P and Q. First they hit U, but there's no angles. Then they hit T. Again, there's no angles here, and there's only one there, so it's not enough to talk about. They do hit S, and they are both perpendicular to S, so that makes them parallel to each other. So P is parallel to Q because both are perpendicular to S. And those are the only lines that are parallel in that picture. That's more of the stuff, the harder questions you're going to be doing is determining what kinds of things are perpendicular or parallel based on those theorems up above. What you're looking for is when you're comparing two parallel lines, you're looking for something they both touch, like P or Q, a transversal, and then you're looking for two angles that you can talk about. Okay?